Hi and welcome to my new video about Apache Spark 3.11 features. So one of big changes in this version of the framework was the support for predicate pushdown in 3 new data sources, which are JSON, CSV and Apache Avro. In this demo, I would like to show you how this support is implemented for JSON, and if you want to discover more details, so if you want to know how it's implemented for Avro and CSV, I invite you to the article which is linked in the description of this video. But anyway, the implementation idea is slightly the same as for JSON, of course, except that of course it uses different libraries for CSV and Avro. But anyway, let's stay sample and focus only on this JSON format here. So this is my code that I will use to demonstrate how the internals of JSON predicate pushdown are working. And you can see that I'm starting by setting the parallelism for the input to 1, just to simplify the debug execution. So later I'm creating a sample data frame that is composed of 3 fields, 2 scalar fields that are supported for the predicate pushdown, and 1 nested field which is, as of today, not supported in predicate pushdown in JSON. So what I will do, so sorry, that's a mistake, I will write these rows to some location on my local disk in JSON format, of course, and later I will read it with JSON data source and specify two different filters. The first filter applies on the top level columns, so these scalar ones, and you will see that it will work. The second filter applies on the nested column, and you will see that the support is not yet implemented for this scenario. And I also a bit complexified this operation and used an OR condition, meaning that this filter expression will apply to 2 different columns. But before running this code in the debug mode, I would like to show you how you can detect by yourself whether the predicates are pushed down to the data source or not. So I simply executed this code with explain that shows all the plans generated by Apache Spark, and you can see in physical plan that in the file scan data source we have something which is called pushed filters, and you can see that in these pushed filters we have 2 different conditions. So the first condition checks whether the nested field is not null, which is something normal, but you can see that we don't see here the filter on the nested field on the top level number 2 of the nested number, so the property of the nested field is not supported. And later you can see also that we have an OR condition involving these 2 top level columns. So that's the first indication how you can check whether or not your query uses the predicate pushdown. So now what I will do is that I will run the code in the debug mode and show you the internals of the execution. So the first thing what happens is that Apache Spark takes all the predicates or to push down and transforms them to the appropriate format. For the JSON, it will be the JSON predicate, and as you can see, it's composed of 2 attributes, the ref count, which represents the number of fields referencing this predicate, and as you can see in our case we have an OR filter condition referenced by 2 different fields. So for this representation the ref count will be equal to 2. And later we of course have the sample condition where the ref count will be 1, and this ref count is quite important in the filtering execution. And the filtering execution that happens here for every JSON line, and it starts by calling the reset method that will will set the counter, the ref count, to the default value, because this value is a variable and it will be decremented every time Spark will see the field involved in the predicate, meaning that it will only be able to execute this condition, this predicate, when the ref count will be 0. And you will see that, by the way, just in a few seconds. So now we are filtering the first row, which is the row number 0, as you can see here. And now we are applying the first predicate, which, as you can see, is our OR predicate. I don't know if you can see it here. Not necessarily. Yes, you can see. Oh no, that's all filter, so you can see it here, but believe me that this first filter is for the first column on the schema, and since we have only one filter involving 2 columns, it will be obviously our OR case that, as you can see, decremented the ref count to 1. And as you can see in this condition here, the filter wasn't applied, simply because we don't know all the values to be sure to apply it. So now we have the second column for the same row, and whether we can apply it or not, you can see that yes, ref count is equal to 0, and if we check the skip, this time it returns true, meaning that the predicate returned false. So yes, that's for the first row. Now we are going to process the second row, but before doing that, since the JSON predicates are shared by all the rows of the document, we have to reset this counter, this mutable counter, and now we will apply the same predicates one by one on the input columns. So we are not going to do the skip equal to false for the first row, but now we will evaluate the second row for the row number 2, and this time it will be, the skip will be true, simply because, remember, in the predicate pushdown we want only to have the rows greater, with one of these 2 fields greater than 3. And of course we are doing sample generation of the input data set. That's why the condition will start to return true only for the 4th and 5th rows. So that's the third row, which will return false. And as you saw, we didn't continue the predicate evaluation. We simply quit this while loop because, as you can see, it's conditioned by this skip row flag. So now for the second, for the next row, the skip row flag is set to false once again, and we start looping on it, of course, by resetting this mutable counter. So that's the number 4, the row number 4, and the row number 4 also returns true in the skip because the value is 3. We start counting from 0. And now we are going to process the row number 5, and as you can see, we already have one column greater than 3, so the skip should remain false for the whole row, and it really happens, at least for this first or based condition. And now we will apply it for the nested column. Of course, that we will have to the nested column that we will have to first convert from the JSON textual format into internal row of Apache Spark. And here, as you can see, we have the root flag set to false, and also the struct filters that previously was set to JSON filters, this time is set to no op filter, meaning that, obviously, as I said before, in Spark 3.11 you can't use the pushdown filters on top of nested fields. So it was skipped just here, and now you can see that we are processing the whole row, the complete row, where we will check, if I'm not mistaken, only the null condition of the nested field. And since the nested field exists, it will return true. And now we will do the last check, if I'm not mistaken. Yes, it's the row number 6. And the row number 6, now we are transforming the nested columns. And the row number 6 is still not skipped, meaning that if we check the results, we will see that we have our 2 expected rows. So as I said, this is general flow, or it's the execution flow dedicated to JSON data source. But if you check the article where I explained also Avro and CSV, you will see that it's very similar. That you will see that the implementation is very similar between all these 3 data sources. And that's by the way, that's the reason why I didn't focus on each of them separately, because it will be, at the end it will be almost the same, except that it will use different filters. So maybe I will just show you quickly what happens for the CSV. Sorry. So CSV uses filters which are called ordered filters, and by the way, it's also the structure which is used by Avro file format, as you can see. And in CSV, so we will create the filters, and later, just below, we will apply every filter to the converted row. And as you can see, we used exactly the same flag, skip row, meaning that when the row should be skipped, so when the row doesn't contain values that will meet the predicate, we will simply return a none here. Otherwise, we will return a required row. And yes, I think that we can terminate here. As I said, you can discover more details of this feature in the article, which is linked in the description of this video. And you can also see in the article, you can also see how Apache Spark uses the new data sources v2 to build JSON, CSV, and Apache Avro readers. It was Bartosz Konieczny from edit4code.com. Thanks for watching.